Real-world environmental and societal problems. Science and technology have brought many benefits and many risks to society and the environment. Sometimes both arise from the same technology. Decisions on the trade-offs between the benefits and risks have to be constantly made. The study of the atom brought X-rays for medicine and nuclear power for energy purposes. However, nuclear weapons also resulted from this science. Quantum physics led to the discovery of the transistor, which revolutionized communications and computing. This has also decreased the amount of privacy experienced by individuals. Plastics contribute to health management in hospitals and safe storage of food, but their waste is long-lasting. GPS satellites use general relativity to account for the time interval difference between the satellites and the ground. Privacy issues are affected by the collection of location data. Steam engines, turbines, and electromagnetic induction made distributed electricity available to many. Turning the turbines has environmental impacts due to fossil fuel burning, damming rivers, installing windmills, and nuclear power plants. The burning of fossil fuels made energy available to many, but also has an impact on the environment, global warming. Nuclear power plants are clean from the standpoint of carbon dioxide emissions, but produce long-lasting radioactive waste. The generation of usable energy in great quantities for society was a major achievement of the 19th and 20th centuries, but it has issues. Energy resources are divided into renewable, such as hydropower, geothermal, biomass, wind and solar, and non-renewable, oil, gas, coal, and uranium sources. All have an impact on the environment in different amounts. Hydropower is very clean, but in some cases communities are moved to make way for a dam. Wind and solar are mostly clean, but both are not consistently available. Burning coal, oil, and gas causes air pollution and increased levels of carbon dioxide in the atmosphere, but they are reliable and efficient. The transportation of fuels can be risky, and the waste from each process needs to be managed. Physics has many applications in daily life. Communications have been revolutionized by the use of transistors and lasers using fiber optics. Electromagnetic waves are used in wireless devices. Lasers are used in medicine in place of cutting by surgical knives. GPS satellites provide accurate maps and recommended routes for travel. Very fast trains are made possible by magnetic levitation, reducing their friction with the track. X-rays and magnetic resonance imaging allow doctors to see within the body to make diagnoses. Gamma rays are used to kill cancerous cells in the body, and the electric power grid is built on power generation, electromagnetic induction, AC circuits, and transformers. There are a variety of environmental issues that need to be addressed by science and technology. Two examples will be explored on the next slides: ozone depletion and climate change. Ozone is a molecule that contains 3 oxygen atoms, O3. The ozone layer is a region of the stratosphere that contains a large amount of ozone. People are down here. Here's a jet flying. This layer absorbs a portion of the ultraviolet radiation emitted by the sun, preventing it from reaching Earth's surface. When chlorine and bromine atoms come into contact with ozone molecules, the ozone is destroyed. Some compounds, such as chlorofluorocarbons, methyl bromide, and carbon tetrachloride, release chlorine and bromine when exposed to UV radiation. These compounds are called ozone-depleting substances, or ODS. Use of these substances, such as CFCs, and that's short for this phrase, in air conditioning units has been regulated, and CFCs have been banned from cosmetic spray cans. They can take 2 to 5 years to reach the stratosphere. As the ozone layer is depleted, there are higher rates of skin cancer, eye cataracts, and damaged crops as more UV rays reach the Earth's surface. Human activities such as burning fossil fuels and agricultural practices have changed the balance of absorbed and reflected energy warming the atmosphere. Greenhouse gases such as carbon dioxide, methane, nitrous oxide, and water vapor trap heat in our atmosphere. While greenhouse gases are needed to maintain a warm temperature on Earth, too many of these gases can warm the Earth too much, global warming, that leads to climate change. Global warming is a temperature increase of the Earth. Climate change covers the results of global warming, flooding, sea level rises, and changes in precipitation, wind patterns, and temperatures. Renewable energy resources are renewed naturally on a human timescale. These include solar energy from the sun, wind energy, and hydropower from flowing water. For example, as water flows from higher elevations to lower elevations, its potential energy is converted into kinetic energy. This energy is harnessed as hydropower. Non-renewable energy resources cannot be replaced on a human timescale. These include coal, oil, natural gas, and nuclear energy. It took approximately 60 to 250 million years for Earth's oil to form, so it can't be renewed quickly. Each form of power generation has its own pros and cons. Burning coal. It's abundant and inexpensive. However, it is finite and greatly pollutes the environment. Nuclear power. Low pollution, high reliability, low operating cost. Cons. Expensive upfront costs creates nuclear waste. Solar power. Abundant, renewable, no pollution. Cons. Expensive upfront costs, requires a lot of space. And hydropower. Abundant, renewable, no pollution. Cons. It is expensive and may disturb the ecosystem. Impact of energy generation. Extraction processes can generate air and water pollution and harm local communities. Transporting fuels from the mine or well can cause air pollution and lead to serious accidents and spills. When the fuels are burned, they emit toxins and greenhouse gases. So here's the goal here, environmental health. We have to store the material, it's consumed, it then has to be disposed. It can either be reused or it is treated as waste. And here's where it's extracted, it's produced and transported, and the circle just goes round and round. Once waste exists, it needs to be dealt with through reuse, recycling, storage, treatment, and/or disposal. All efforts must be made to avoid waste entering the environment. The accumulation of both water waste and solid waste is called sewage. There's a variety of treatments to dispose of different types of waste. Physical treatment focuses on concentrating, solidifying, or reducing the volume of waste. Chemical treatment is where changing hazardous waste into non-toxic waste, or by changing the chemical properties of the waste. Biological treatment focuses on the stabilization of organic matter so as to prevent the emission of harmful gases. Thermal treatment includes any process that employs very high temperatures to manage waste. The United States Environmental Protection Agency, EPA, created a waste management hierarchy that categorizes the steps necessary to manage waste in a method that benefits people and reduces the impact on the environment. The EPA is in the process of revising the hierarchy to take into account new data. So here's the most preferred up here down to the least. Source reduction and reuse, recycling, composting, energy recovery, and finally, the least preferred, treatment and disposal. Recycling involves collecting waste that can be sorted and processed into raw materials. These raw materials can then be remanufactured into new products. Recycling has numerous benefits, including preventing gas emissions, creating jobs, saving energy, and reducing the need for landfills and incinerators. When plastic is recycled, it is sorted and shredded. These shards are then melted down to create pellets, which are used to create new products. However, each time plastic is recycled, it loses some of its quality. Glass can be endlessly recycled by crushing, blending, and melting it together into new products. Unlike plastic, glass can be recycled almost without limit with no loss of quality. It is important to conserve Earth's natural resources so they do not run out. It took millions of years for oil to form underground, and humans have learned to extract and use that oil for energy. The extraction process and use of oil takes carbon that was trapped underground and releases it back into the ecosystem, impacting the Earth's climate. Reducing energy use and shifting to renewable energy sources such as solar and wind can help conserve natural resources. Consumers can choose to purchase items that are made from recycled materials, completing the recycling chain. Environmentally friendly consumer products include LED light bulbs, buying clothes made from recycled fabrics, reusing shopping bags, and refilling reusable water bottles. Companies could omit certain pollutants and dangerous chemicals from their ingredient lists to lower the amount of these chemicals making their way into the ecosystem.